total general lighting load of 11,700, first 3 VA, and that after 35% is 3,000, comes out to a total of 6,045. This is the part I was saying, okay, so how many circuits do you have to bring by? How many breakers are gonna be required for this?
75 questions worth of code homework that we have to
So that's a
turn
VA.
in today.
Your breakers are sized
Does it
in,
do? Does it have a time?
It's due today at 5:30 p.m.
breakers are sized in amps
She assigned it this morning.
by,
There's 2 of them, there's chapter 5.
what's our voltage on lighting loads?
Both of them are due
Yep,
today.
so you take the
Do you see what she
6,045
posted?
I don't
divided by
think I counted these
120
right there
volts.
last night.
How did
And
you
that will give you amps.
How did you get to the 6,045? What per?
Yeah, there's 50 in the first one. 25
Right
in the
down there,
second.
number 7, net general lighting load.
Yep.
Right, so it's a square feet, 7,200.
Right.
Then we add in 2 small appliance circuits,
Okay.
right, of 1,500 each. Then you add in the laundry circuit, which is 1,500. Comes out to a total of 11,700,
Gotcha.
right? First 3,000 is at 100%. So they want you to size 3,000 watts at 100%. Anything beyond that is only 35%. And that's what this line does, right? So the first 3,000 is 3,000, right? And then the remainder, so you take your total general lighting load, subtract 3,000, which is 8,700, multiply by 0.35,
Gives you that.
and that comes out to 3,045. So you take the first 3,000, add it to the 35%, that comes to 6,045.
Gotcha.
Yep.
Wouldn't you use the total general lighting load for the branch circuit, for the branch circuit calculation? Cause just cause it takes that 35% doesn't mean the other total doesn't exist. Why do you use the reduced version instead of the branch circuit? I mean, I get that you don't use, like, use 3,000, 100% and 35%.
It's,
But the other, what's left, but before the 35% still exists, wouldn't that be the branch circuit calculation instead?
with this number that we're using for the number of amps,
Yeah, maybe 11,000 instead.
well, let's just compare that. Let's do this one first. So how many amps is general lighting gonna take? 50? 50. Yeah, 50.37, all right. Okay. As compared to if we went with a full amount, 11,700, right? Divided by 120.
I have to animate the.
97 amps. Yeah. Which really. Right. So here's the rationale, right? If 97 amps was required just for lighting and 200 amp service, that's the part that I was trying to get at. 200 amp service is quite large, right? You know, half of it would be dedicated just for lighting, which if you're in a commercial structure, maybe that's true. It's on all the time, but in residential, that's why they do a D-rate. Most of the time, it's not on, right? You're on at this time of day, right, 4 to 9 p.m., and then in the morning, it's off at night when you're sleeping, it's off during the day when you go to work, for most times, it's white out anyways, right? So that's why they D-rate it. Good question so far. Okay, so what do I do with this number now? To determine the branch circuits. Got 50 amps, 50 plus, 50 plus. So, you can divide it by 15 or you can divide it by 20. What's that? The size of your breakers. The size of the breakers determine when it comes to this, right? 15 amps or 20 amps, that determines what?
How many circuits? Branch circuits?
Okay, it would determine the number of branch circuits, but more importantly is the wire I have to use for those branch circuits, the size of the conductors, right? So once you pick a breaker, right, by code, you have to use a certain size wire. Now, if this is general lighting, right, contractors will choose this one, because a 15 amp circuit only requires, alright, this is that 14 gauge wire, AWG. And this one's at, what size wire I have to use for 20 amp? 12. Now, in residential circuits, you think of all the lighting in your house, right? You gotta go all over the place to provide lights for your house, right? And if you use 12 gauge wire compared to 14 gauge wire, could be quite a cost savings, right? As to which one you use. So if we go with 15 amp, right, we gotta have 4 circuits. If we go with 20 amps, I only need 3 circuits. These would be 3 20 amp breakers with 12 gauge wire. This would be 4 15 amp breakers with 14 gauge wire. So even though this one requires 1 more breaker, the wire size is a lot smaller. It's easier to pull, it's easier to install, it's easier to, you've been using 14 all semester, it's easier to make terminal loops and connections and wire nuts and all that, right? So there isn't an advantage to sizing that 15 and 20. So let's say we pick this one, all right? So if we list the circuits, right, required in the panel, right? The number of breakers in the panel that you need. How many do we need? 4 15 amp at 120 volts and 14 AWG copper, right? most braided circuits are copper. They're ready. Tell us copper. You're specifying. This is general lighting. Two-story house, how would you divide them up? Two upstairs, two downstairs? Right, and then you gotta figure, well, they want the bedrooms on one, hallways on another, you just gotta, probably the design engineer or plans would break that up as to how those circuits are distributed for lighting in the house. What else do we need just in this first section? Is this all of them?
Laundry circuit?
What's on? Which ones? Laundry? Gotta have one laundry circuit. It's 1,500 VA. That's a 120 volt circuit. So I could use a 15 amp, 14 gauge. Generally on these dedicated circuits, you just go from the panel to the laundry. It's better to use 20s, right? It's better to use 20s. And I think in the book it said that it's supposed to be a 20 amp circuit. Okay. Go with that. So it's a 20. NM, probably be better term, non-metallic sheet zinc rather than copper. And then what else you need? Yeah. Got two of those. Those are generally 20 amp, 120 volts. Yeah, 20. So in the panel box, we've already used 7 spots, right? Where the breaker's going there, we've already used 7 spots. What's not included in this first part that it says you are required to have, that don't count towards the VA, but it says you have to have them listed here. Other parts of your house that aren't included here. You got general lighting, laundry, small appliance. What other parts of the house are there?
Bathroom.
Bathroom. Right, you gotta have a bathroom circuit. And then, and on the list, it was what, how many bathrooms were there?
2.
2 bathrooms, right? It doesn't go towards calculations, but you gotta provide them in the panel, right? They don't go towards the VA calculation, so you gotta have bathroom circuits. And how you wire them, you know, they went in saying, well, if you hook lights to it, you know, you know, you can't wire both bathrooms on the same circuit, right? You can't run the bathroom fan on the same circuit if you feed both of them on one circuit. There's a whole list of things that you can and can't do. There's a chart with the different circuits on them. You know, you could get away with one circuit feeding both bathrooms. But in order to put the vanity light in, it has to be on its own circuit, each bathroom, right? If you just put receptacles in the bathroom on that circuit, you can put both of them down. But that, you know, your vanity light you can't have on it. So you might better put 2 20 amp at 120 volts. That's 12 AWG, 12 gauge NF. There's 2 more spots in your piano. What other things do you need in that first part that's not available? Rami, what else you gotta have? Put that thing down and pay attention. Every time I look at you, you're. No, I'm looking at you, man. Don't look at other people. All right. So what else you need? I'll get to the other ones here in a minute. What's the list? I listed all the stuff out there.
Oh, I don't have it with me.
Why not? Why aren't you looking at it on your phone? Pay attention, be involved with what we're doing. Where is the list, guys? How come you don't have it out? Yeah, Mr. McNair, what else was on the list? Beyond that, not attached appliances.
Kitchen.
That's the small appliances. The garage. The garage is a circuit that you need to include, right? We're gonna get to the openers in just a second. Yeah, that's an attached appliance, right? So you gotta add a garage circuit. Might as well make it 20 amps.
So this house is like built in 30 by 40 and there's a garage inside that 30 by 40 space.
Oh, it's not livable.
No, it's not livable space, right?
Where's the
Oh.
bedrooms?
The bedrooms are livable space.
Well, no, I'm not. I was just thinking because I thought you would include that into your general lighting square footage.
The general lighting category is only for livable space. So like basements, if it's a full basement underneath, you gotta provide a circuit. I didn't tell you we had a full basement.
But
You have to provide a circuit for it, but it doesn't come into the calculation for general lighting load.
so general lighting is just for
Livable
spaces.
Absolutely,
Oh,
right.
okay.
Find that there, Mr. Rami?
Yeah.
Nice. Try to keep your attention. I only have a couple more weeks to yell at you.
Our final gonna be a take-home
When's the final due? Yeah, you do. When's the final due?
Wait, is this our final? Let's do Wednesday.
Yeah.
Oh, I thought our final was due. I thought it was just like a homework.
It was homework. It was a homework.
Just another assessment.
No, This, right, I told you, right, who didn't get a printout?
I don't think you
Right,
mentioned it more.
this is part of the final,
Oh, pause.
this is the other part of the final. This is worth 60 points, 61 points. This is only worth 39.
Okay, why is that, why is it 6139?
Because there's 39 questions.
Oh. I'm like,
You want half point for this one?
I mean, you could at
and-
least do a 60-40, you kind of.
Yeah, exactly, but there's only 39.
I mean, you can
Well,
do-
I give you a point for putting your name on every sheet, how's that?
Okay, that's.
So it's
that's,
60-40.
Okay, that
Alright.
makes my common sense. No. Maybe we have.
So we don't have anything final, what are we doing?
Oh, finals week, be service entrance stuff. And maybe a question here and there from the rest of the semester.
70%.
Yeah, we got a final. I don't like it if I don't give you a final. This is just exam number 2.
That's what I was asking.
Yeah.
So
Oh,
this isn't a final.
well, this is exam number 2. Yeah.
So we're gonna have final.
But it's,
Are we gonna have like an in-class final?
no, I'll have another thing we take.
Is it gonna be due?
I lost.
Yeah. Whenever our final time is scheduled, that's when you get it turned in and somewhere, 'cause I probably won't be here. So you turn it in the office, my mailbox. We'll figure that out.
Trapped and tomorrow they just plumb it right down.
It's like,
That's
Okay,
that's
so-
fine. How long is that?
When you fill these out, where do you put the letters?
is that like, it's like-
Right on the side, right? The letter, capital, just like exam 1. Made it clear as to which one you wanted to.
Do you want that as a paper copy when you?
Like this?
Cause I did it on my computer when we post it. You don't really print it off.
Yeah, please.
Okay.
Yeah. And if you can write the letter, right next to the selection. So that way I can just, I'll have a key, just.
And the highest I can get is an 82.
Yeah, so if you can print it out, put your name on each page, put your name on each page, right? And resubmit this date. Okay. Okay, so my list, I asked you to include the microwave, right? We didn't have a bathroom fan. But what other attached appliance did we have?
Higher than the 70.
Garbage disposal.
Yeah. So when you print this out, you can just draw a line through it, put garbage disposal, right?
Just-
Oh yeah, it's there. What was another one that we didn't have? The door openers? Yep, you could do that. There's 2 of them. You only need 1 circuit for them. So how do I calculate the VA that goes out there? What is it, 2.5 amps? What did it say? Mr. McNair? 3 amps at 120 volts. Door openers. Times 2. So 3 times 120 is 360, times 2 is 720, right? So you could put that where the bathroom fan was, right? So you do, if it doesn't give you the VA, you do amps times volts, that gives you the VA. Microwave, dishwasher, what was out there? What do you have for others there? Freezer, refrigerator. So, the air conditioner, it's kind of the HVAC thing. So we'll wait on that down there, right? Right. Yeah, the dryers down here, the range, right, the big ones are down in this section, right? And it says be 5,000 minimum, so you just put 5,000 there. Oven, we have a gas range. Now, but the gas range still needs a breaker, right? But it doesn't really go into the calculation, right? You gotta have a circuit. Even though I don't have an electric oven, I gotta provide an outlet to plug in the control panel to. So you gotta have a breaker for that. You gotta have a breaker for each individual attached appliance. Okay? Right? You gotta have one for the garbage disposal. Rather than the bathroom fan, it'll be the overhead doors, the microwave, the dishwasher, freezer, refrigerator. See how this works?
You want us to do it on there, print it out, and then do the rest of it?
Yeah, and then do, well, I don't like writing on the back, just use another piece of paper with your name, date, circuits, list, title.
How about them kids?
So these are all single breakers, right? Now, before I move on, now, this says for your attached appliances, if you have 3 or less, which we have more than 3, right? 3 or less is just the total of the VA. If it's more, it's only 75% of the total, okay? And it'll calculate it in there, right? So you got garage doors, freezer, refrigerator, what else is on there? Anything else that goes as attached appliance? That's there. Microwave, I said to use 1,000 watt for a microwave circuit. So we got enough room for all that? Right? So what it's gonna do is it'll automatically, you'll have a total, and then because there's more than 4, it'll only be 75% of that total for fixed appliances. So far, so good? Right? And then this section down here, well, we don't have a range, right? Just let go. HVAC, yes, put in, how many watts was it? For the AC unit.
This is too much for a minute.
I need this,
And it says 12 amps,
I'm taking a video of it that I'll send to you.
240.
thank you.
flash 120.
Right.
One of my zebras were the ones with the name, I think, because I've got a 0.
How many amps?
Because you should
12
have gotten at
amps
least,
at
I know we're like years
240
over,
volts.
300 years now. I think you should have gotten at least a 70 because it was 47
What did
right
you
now.
get?
I got a 71 now.
Yeah, I probably would have gotten around there, 70, 60.
So how many
The only thing
VA?
that messed up was total breaker size.
That was
What was in that spot?
I still don't understand why it's not 200 amps, but I'll have to look that up.
Yeah.
Oh, wait.
10 would be 24.
2000.
2,000.
Total. Because I need to do like this, the first 3,000 is 100.
Right?
Anything after 2,000.
2,000,
35%.
yes.
So we gotta multiply it by that.
Right.
And it gave us 97 for the total, so we should have only used 100, I guess.
I think I used the number 75 instead of 35.
So, it needs 240 and it needs 120. Now where that comes in, right, because eventually you're gonna get down to that section, these are the double breakers.
Because I wound up with like 178.8.
Right? So the AC unit needs one DP-ST breaker. Double pole single throw, it's the double ones like the last lab we did, right? How many amps for this thing? Well, they don't make a 12 amp breaker. 15 would work, right? So that's 15 amps at 240. In these units, they also have a 120 volt line. So for a strict 240, right, this would be 14 AWG. How many conductors do I need for 240/120? 2 conductors gives me 240, just like we did in lab. If I need a 120 line, add another one, right? So this would be, these were 12 gauge, right? This is 3 wire. 14/3 with ground, right? And that would give you 240 and 120. So hot to neutral, right, is 120, or neutral to hot is the other 120. But you need a neutral for the 120 control circuit. But it's still just a single double pole circuit breaker.
So that's if you just put it,
The white would go to the neutral bar, the 2 hots would go,
and then one.
yep, and 1 on neutral.
Same price.
Yep, and the bare bonding wire, yep. So the double breakers are down here, we got a dryer, that's 5,000 VA. So how much current? This one was only 2,800 and we were at 12 amps. This is almost twice as much, more than, well, not quite 20.8. So can I use a 20 amp breaker? 25s are very rare. What they'll put in is a 30, right? Now, if I use a 30 amp breaker,